Hello, calculus fans. All right, let's use the second derivative test to classify the critical numbers of the function f of x equals x to the fifth minus 5x to the fourth. Notice that there is the phrase if possible. Remember that part of the conclusion of the second derivative test is that it may be inconclusive, and so we have to keep an eye out for that. All right, if we're going to classify the critical numbers, we have to know what the critical numbers are. So let's take a derivative and set it equal to 0. So the derivative is 5x to the fourth minus 20x cubed. That's easy enough. And we'll set that equal to 0 now. So we're looking for critical numbers, so we set this equal to 0. We can factor out the 5x cubed. So we end up with 5x cubed times x minus 4. And so that means there have to be two critical numbers, x equals 0 and x equals 4. So remember that we're going to plug in these values into the second derivative to see what we get. All right, well, let's compute the second derivative. All right, also easy to calculate the second derivative. We'll get 20x cubed minus 60x squared. And then we factor out the 20x squared, and so we end up with 20x squared times x minus 3. All right, well, now we can classify our critical numbers, which were 0 and 4. So we'll do this by plugging in those critical numbers into the second derivative. Now, we're just trying to see if the second derivative is positive or negative. We don't really care beyond that. So if we plug a 4 into this expression, it's pretty easy to see that we're going to get a positive number. Don't really care what the positive number is. That means the curve is concave up at that point, so there's a local minimum at x equals 4. But the next thing to notice is that if we were to plug in 0 into this, then we'd get us 0 for the second derivative. That means that the second derivative is inconclusive at that point. Now, it's very important to understand what that means. Inconclusive just means we don't know. It doesn't mean that there isn't a local extremum at that point. It just means that the second derivative does not say whether there is or there is not. I would like to point out that the first derivative test is never inconclusive. If you go back and look at what the first derivative test tells you, it is always answering a conclusion. It never tells you, I don't know. Whereas the second derivative test has the possibility of saying we don't know what the answer is. So a lot of times if you're going to use the second derivative test, you may occasionally have to fall back on the first derivative test to answer the question about classifying the critical numbers. Okay, that's all for now.